Hello, we're looking at stoichiometry, where we're looking at the relationship between the relative quantities of substances taking part in a reaction. And so, let's do this problem. How many grams of nitrogen are needed to prepare 888 grams of ammonia? That's part A. Part B, how many grams of hydrogen are required for this reaction? So let's see what we're after and what we have in this problem. So how many grams of nitrogen? We want to know how many grams of nitrogen. Now that's not atomic nitrogen. We don't find atomic nitrogen in nature. It's always a diatomic molecular species. So it's going to be grams of N2. And we want to know how many grams of nitrogen we need if we want to prepare exactly 888 grams of ammonia. So 888 grams of ammonia is what we're given. And the grams of nitrogens are unknown in part A. So our roadmap in all these stoichiometry problems is to go from grams to moles to moles to grams. Whenever we're going from grams to moles, we're going to use the molar mass of the respective compound, the formula mass. When we're going from moles to moles, we're going to use the pertinent stoichiometric ratio that shows how the relative amounts react with each other. Now to do that, we've got to have a balanced chemical equation. So what reaction are we looking at? We're looking at molecular nitrogen plus hydrogen, and just like nitrogen, hydrogen in nature is a diatomic molecular species. So N2 plus H2 reacts to make ammonia, whose formula is NH3. We need to have a balanced chemical equation. We've got two nitrogens on the reactant side, try 2 in front of the ammonia on the product side. So now the nitrogen's balanced. The hydrogens, if you looked at the products, I've got 2 times 3 hydrogens, that's 6 hydrogens. So on the reactant side, in front of the H2, I need a 3. So this is my balanced chemical equation. It says that 1 mole of nitrogen reacts with 3 moles of hydrogen to make 2 moles of ammonia. 1 part nitrogen plus 3 parts hydrogen makes 2 parts of ammonia. So we're going to start out with 888 grams of ammonia. We will change that to moles of ammonia. So we need to know the molar mass of ammonia. We get that from the periodic table. It's 17.0 grams. So now grams of ammonia cancels. I've got moles of ammonia. Now I need my stoichiometric ratio that will convert moles of ammonia, the product, to moles nitrogen, the reactant. And so my ratio is 1 mole of nitrogen to 2 moles of ammonia. Now moles of ammonia cancels. I've got moles N2, which I want to cancel, so that goes in the denominator. And I need the molar mass of N2, which is 28 grams of N2. And so I'm very careful with my units. I'm putting in my units of grams and moles, and also a descriptor of what goes with those grams and moles. So moles nitrogen divided by moles nitrogen, that gives us grams of nitrogen. So 888 divided by 17 times 1 divided by 2 times 28 would give me 731 grams of nitrogen. So that's part A. So part B, let's find out how many grams of hydrogen are required to make this 888 grams. So once again, we're going to go from grams to moles, moles to moles, and moles to grams. This time we want to wind up with grams of nitrogen. So we have 731 grams of nitrogen. So 888 grams of ammonia, 1 mole of ammonia is the same as 17 grams of ammonia. Now we want to do moles hydrogen. To moles of ammonia. Because grams ammonia divided by grams ammonia. Moles ammonia divided by moles of ammonia. And now my stoichiometric ratio is 3 moles of hydrogen to 2 moles of ammonia. And then we want to go to cancel out my moles of hydrogen, grams of hydrogen, so we're going to use a molar mass of H2, which would be 2.02 grams. And that'll give us grams of hydrogen, moles hydrogen divided by moles hydrogen. So 888 divided by 17 times 3 divided by 2 times 2.02, and that will give me 158 grams of hydrogen. The 3 sig figs. Now the law of conservation of mass says my grams of reactant should equal my grams of product. So my grams nitrogen plus grams hydrogen should equal my grams of ammonia. So I made 888 grams of ammonia. We said that requires 731 grams of nitrogen and 158 grams of hydrogen. So 731 plus 158 is going to be 889 grams of hydrogen and 888 grams of ammonia. So remember, we're doing significant figures here, so plus or minus 1, that last digit, we've just got some rounding error in here. If we were to carry this out to a few more digits, we would come up with the exact answers. So don't let that throw you off. Now, if I'd come up with 899 grams, something's amiss. And so just plus or minus 1, that last digit, we can tolerate that, recognizing that we are limited by our significant figures. So that's an example of another example of stoichiometry.